So the story I'd like to tell you about is a customer who was developing a very rural telemetry solution. So they needed to be able to get reliably connected to devices which were installed across Africa, in fact, and they were looking for very rural locations and getting telemetry data to and from those devices. So the problem they'd come across was that they built the IoT application that they wanted. They'd got the sensors, they got the interface working, but they were struggling with the communications part. And they looked at a number of solutions. So one of the solutions they'd looked at was actually taking a 4G dongle and a small computer, and they were connecting the dongle to the computer, and they were trying to bring up a connection and then use that as an internet connection to send the data back. They'd looked at another solution where they'd taken a cellular modem and they'd written their own code to try and get the device connected to the network and sending the data. But in each case, they'd found that there were challenges once the devices were installed in the field. And of course, this is where the problem really occurs, because when they've got something on the bench and they're testing it, then they can see that it's working and it looks lovely. The problem is, as soon as you've taken it out into the field, you've driven for, in this case, the customer had one site that was 14 hours drive away. You've driven for that length of time, you've installed it. If you've then got to go and visit that device because there's a technical problem, that is an absolute disaster, and it will prevent any scalability of a project at all. So what they asked us to do was look at how they could reliably get the connection so that they could deliver data back to the cloud that they were going to be using. So the way we did that was, first of all, we actually looked at the project they were using, and one of the things we realised was that power was really a real issue for them. The remote devices were running off a battery and solar power, but they had to charge the batteries during the day and then run off the batteries during the night to give 24 hours a day connectivity. So that meant that actually the power use of the modem really mattered, and we needed to get the power consumption down to an absolute minimum. So the way we did that was we looked at taking a low power modem. In fact, because of where they were using, we actually ended up on a 2G solution. But for future proofing, we put in a modem which could go Cat-M1 and LTE-M and 2G as well. So we built a solution around this modem, and we put in a lot of power management to allow the modem to connect reliably when it needed to connect, but shut off when it didn't. The second thing we did was we actually took our library of code, so we've already got functions which can connect to the network reliably, and we used those and we implemented those on a small circuit board. So along with some power management features, we actually added some environmental sensors as well, so that we could understand how the device was operating, what the environment was like. And then we provided a serial interface to the customer's IoT device itself. So now, as far as the customer is concerned, instead of having to worry about all the connectivity part, the modem, how you actually connect that modem up, what the power supply for that looks like, we could provide them with a simple connector which was easy for them to connect to the battery that they were using. We provide them with additional battery monitoring circuit on that, and all they needed to do was, from their microcontroller, read the data from their sensors, from the environmental sensors, provide the information, they had some users, provide the information on the display as well, and then just send simple commands: please send this data to the cloud. And then when we received data from the cloud, we were then able to present it on a serial interface to the device. And that gave them a number of advantages. The first was, it meant that they could go from having to worry about the hardware and software design of this component back to just being able to concentrate on the bit that they needed to do, which was the interface and the connectivity, and the interface and the sensors. So they concentrated on that, we provided them with the connectivity. The other thing that it gave them was increased reliability. Because we were able to use library code that's been well tested and well proven, it meant that we were able to connect directly into the cloud using facilities that we have tested and used in a significant number of occasions in the past. And this gave them a reliable connection. So now, as far as the customer is concerned, they can fire up their device, it will take the measurements, and when they've got data to send, they request the circuit board that we built for them to send that data, and we're responsible for delivering it into the cloud.